Okay, let's get started. Hello, good evening, afternoon, morning, whatever you have. Um, so my name is Vaclav Petras. I usually go by Vašek, and I will be talking about Newgrass Python API. Um, the work you will see today was sponsored by Natrix and through an NSF SBRR grant they got from the National Science Foundation here in the US. And Natrix is a company which builds things like this coastal infrastructure you see, which is supporting balance between natural and built environments. And to place that infrastructure, they do a lot of geospatial planning, and for a significant part of it, they are using grass. And as part of that, we were working on several things in Grass. If Grass is new to you, Grass is an open source, multi-institutional and grassroots project for geospatial processing and geospatial modeling. Uh, it uh, it is very multi-institutional in the sense that there is 10 different affiliations just on the core development team. That doesn't count the broader community or even the project steering committee. Big piece about the grass is that it is backed by science. One way how this is demonstrated is that the Google Scholar profile of the grass project tracks now over 50K related citations. Grass is a project of OSGeo and project of NumFocus, which provide infrastructure and uh, uh, fiscal backing for Grass. So the sponsorship in this case goes through NumFocus. My name, as I said, is Václav Petras, and I worked on this project together with Anna Petrashova. We are part of Center for Geospatial Analytics at NC State University. Anna is now in the chat. If you have some questions which you can't hold for the Q&A at the end, you can post them to chat. We may answer them right away or leave them to the Q&A, but at the end there will be time for you to ask either live or through chat at the end of the presentation. The new Grass Python API, what it is achieving is that the API should minimize friction when using Grass tools in Python. And of course, the first question is why do we need an API? We already actually have API. We have more than one. So it's sort of like this classic joke where we have 14 competing standards, which is of course ridiculous, and we need one standard which fits them all. So then the situation at the end is that we have 15 competing standards. So are there good reasons to get another API? I hope I will convince you that there are, and I think that hopefully the new API will be the one API to rule them all in this case. So you can use Grass tools from Python without any special Python API from Grass. You can just use the Python subprocess package and run Grass tools as subprocesses. Assuming that you are in a Grass session already, you have a project set up and things like that. You can run the tools, the syntax is reasonable. So if we are building a new API, we need to do something which is better than this. Otherwise, we shouldn't be building any API. And we do have a couple current APIs in Grass. We have this run command family of functions in the Grass script package. The development of this stemmed from transition from Bash to Python, but unfortunately the syntax is much more heavy than the syntax in command line, and the function names in this API are prominent because function names would be prominent when you are writing the code. The issue is that these prominent function names are not the tool names. The tool name is only a parameter and a string. Then also there are different functions for different use cases. When you are just running a tool and don't expect any textual output being captured in Python, you use run command. When you want to capture output, you do parse command or read command. When you want to write text to the tool or pipe to text to the tool, you use write command. So there is you have to switch in between these, and these instead of focusing on the tools themselves. Another alternative in Grass API is a module class, which is part of Grass PyGrass API. And there the idea is that each tool is an object. So there is a class module, today you probably call it a tool, which represents the tool and allows us to run it. It also represents the output of the tool. If we are capturing the output of the tool, the object will then represent the output, and we will manipulate the output through the object. The thing is that then in the API we have this mix of the tool parameters and the tool outputs. So it's not always clear which one is which. Sometimes the outputs you think about them as the rasters which the tool is outputting. Sometimes this will be the standard output, the text output, which then needs to be parsed if it is a JSON. So you do other additional step to parse it. If you are actually capturing the output, you have to say it specifically you want to do it. And then the tool name is still a parameter rather than a name in Python, as similar to the run command family of functions. PyGrass itself is trying to compensate that by introducing these shortcuts. So in PyGrass modules shortcuts, there are these different objects, which depending on how you import them, you can achieve a syntax similar to command line, where you would say something like rslope aspect and then the parameters. The thing is that how this is set up is that you need to import them in a very specific way. You see that there is the import alias raster as R, and then it will give you kind of the feel of command line. You can also import it just as a raster or raster as a doc, and then you would have doc.slope aspect. So that creates additional layer of need for consistency. And also there is certain confusion in where is the dot in the name and where is the underscore in the name. And then, well, it's really a name. So names in Python, they use snake case. They don't use combination of dots and underscores. The dot really just comes to copy again the command line syntax. So that's not great either. And then it suffers from the same output and result handling issues as the standard modules class. So for the new API, I identified a series of goals. One is that it should be centered around the tools. The tools are very important in Grass. We have 400 processing tools just in course and another 400 tools in Grass add-ons, plus 100 or 200 of support tools. And I wanted these tools to be accessible as Python functions. If it is a function in Python, then we immediately think about having a return value if it is appropriate, and then functions raise exceptions on error. Then I wanted the processing of the common outputs to happen automatically. And I wanted to have such defaults that, like default parameters and default behavior, that it would cover the most common cases. And then for the less common cases, we can do customizations, and the API is also general enough that it would allow alternative implementations of this API in other contexts. And then I also had some things which I don't want the API to look like. So I didn't want to uh, resolve to radically different approaches for advanced use cases. So I want the advanced use cases to be just as simple and straightforward as the basic use cases. And I also wanted to avoid introducing additional wrapper functions, which would make the common cases more convenient. So for common cases like gRegion or rinfo in the run command family of functions, we have convenient wrappers, which make it more easy to use. But I want this to be convenient for everything. So the solutions need to be general enough to make it convenient for everything. And generally, I just didn't want the API to get in a way of like a Python workflow. So the API we have now, which is now available for testing on the main branch, it lives in grass.tools, and there is an object tools. So that's a new thing, and it will become more clear why we have an object later on. So you first create an object tools, and then you call a specific function or a tool as a function call. So for example, tools.rgrow, the function name, of course, is with underscores in Python. So the tool name, uh, usually in Grass have dots. In this case, it has underscores. And then the parameters of the tool are parameters of the function. That's similar to the previous interfaces. What the object returns is something which you can right away use. So for the tools which actually where you are capturing the output in Python, like for gRegion with the flag p, you are expecting to get the values in Python. So if you combine this with the recent additions of JSON outputs, this creates a really nice API where you just index the result object with whatever you need. In this case, I'm getting number of cells in the current computation region, and I can assign to the variable, and it works as is. The result object, which is what is returned by the function, has several different attributes and functions which allow us to either access the original standard output of the tool with stdout, or there are more higher level attributes like text or keyval, which give us text as a string rather than the bytes. And in case of keyval, this is parsing the key value format, which is the classic format, which, for example, gRegion would give. If you did some scripting, that would be gRegion minus G. Another thing is that in more detail, the result object has an high understanding of what are the possible outputs, like the JSON or the key value format. What is important that none of this happens unless the user actually requests that. So here, when I am indexing the result of runivar with mean, the JSON parsing happens at that time when I'm indexing it, not before it. The result object doesn't make any assumptions unless the user interacts with the object. So I can assign the result object to a variable result, and then later I can index it. The parsed JSON is cached in this case in the result object, So in whichever way I approach it, it is not less efficient than if I would be doing it manually, like in the previous APIs where you typically parse it manually with JSON, with the JSON package. Here it's all in the background, but it's as efficient if you would be doing it manually. The JSON edition is really important. You uh, to complement this API. So this wouldn't be actually even possible or that nice if we wouldn't have the JSON outputs. So you can see it even with the run command family or with the parse command function specifically here is before 8.4 runivar would return this key value shell script style output with the flag G, and you would get a string uh, for the mean. If you can index it, but you get a mean. But since version 8.4, if you use JSON, the parse command function will give you the parsed JSON, and uh, that will have actually the floating point type. So that's much nicer. The thing is, it really works only with the specific format equals JSON, while in the new tools API, there is no assumption about the parameters of the tool. It's really about how the user interacts with the result. Another thing is that if if there is no output from the tool actually doesn't, uh, or the functions don't return anything. They return none in Python. So running rslope aspect, which creates in this case, a slope map in the Grass project, but nothing is loaded into Python. The function just returns none. This is this might not be always good for automation of running tools. So you can request a consistent return value when you are creating the tools object. And here we see the first place where having the tools object gives us an advantage, where we can put their additional requirements for the behavior of the tools or the functions without cluttering the actual code of the tool calling. So we create a tools object in a specific way, and then the tools are then called in the same way as before. And the most common way how a tool object would be used is in a combination with session or session-like objects. So here is sort of a complete workflow in Python where we create a project. In this case, it would be an XY project called project. And then we create a session with GS setup in it. And here we copy the global environment to this session. So the global environment is not affected. It doesn't know anything about Grass. It's only the environment linked to this session would know something about how to run Grass tools and which project to use. And we pass this session to the tools object. We could also pass specifically the environment itself. And now it is the same as we were using it before. Before we were just assuming we were already in Grass session. And the syntax here is the same. We just do tools dot gRegion r random surface, and we don't deal with is this a session? Are we passing environment, or even are we capturing or returning the consistent return value or not? That's already resolved on the line which creates the tools object. And the tools object itself, it can work as a context manager, which applies to the session as well. So these two combine well together within one Swift statement in Python. So that would also combine with other context managers. So you can all uh, create all these in just one with statement. And at the end of the with statement, all the things are cleaned, destroyed, and uh, you can restart your workflow or whatever is appropriate for these context managers. And we will see more of this soon. And as if you recall from my goals, I wanted the advanced use cases to be just as simple as the basic ones. So you can use the functions as Python function or the tools as Python function names. So that would be the g underscore region and um, and this gives the result object, which has all these nice properties, these nice attributes JSON parsing I was talking about before. But sometimes maybe you are doing a lot of automation and your tool is really just stored as a string in a variable. So in that case, you can use function run and it will return the same type of result. You can even pass a list of strings, like on the last line, which is very similar to what Python subprocess package would require. With the runcmd function, you pass this list of strings, which are which is the name of the tool and in the individual parameters, and then you get the same result object. And if you are going into low-level functionality, then you are interested in low-level outputs, like the return code of the tool, standard error output or standard output, and you can get all these from the result object. And there again, that's where the consistent return value would be probably interesting. As I mentioned, the tool works with the session. It can also work with a custom environment. If you are setting up the environment in some other way, or you influence the environment in some way, you can just pass it to the tools. And then all the tools which you use with this tools object you just created share that environment or session. This is very useful for parallelization or nested sessions. But if your workflow requires something uh, like passing different environment to each tool, that's still possible. So that would be, this is now an additional way how to do it, but with the run command functions and the PyGrass modules class, this was the only way how to do it. Each tool call would have to have its environment passed separately. So we don't have to do it now, we just do it once. And all the tools which you want will share it. But what is really interesting and really nice, which uh, hopefully is not advanced, but rather something which will be used quite a bit, is that instead of passing a raster name, you can pass an NumPy array to the tool, and the API will process it in the background automatically into a grass raster. So you can if you set up your region right so it fits with your arrays, you can switch it from one workflow to another when both of these when one of them is using NumPy, the other is using Grass. You could do this without this API, but this API just wraps everything into a nice package, and you don't have to do any of the transformations yourself. And the syntax is again very natural. You just pass it as a parameter, and the API figures out the rest. For the output, you have to let's say, do an extra step to tell it that you want an output. You want to output a NumPy array, and how you tell it to the API is that you, instead of putting there the name of the raster, you put there np array or np-nd array, which is either the function name or the class name of NumPy arrays. And when the API sees that, it knows you want it to return an NumPy array instead of generating grass raster. If there is more than one, it will return a tuple. It is also working with the consistent return value. So if you are automating again, you can make this very clear even with the NumPy interface. There is a tutorial which is using it. It's using Grass, NumPy, and LandLab all together. So that's already published on the Grass tutorials website. And I just don't think the NumPy arrays are enough. Another addition which which this API can do for the tools is that it can automatically import Grass native rasters. With Grass, you can export Grass native rasters, keeping the Grass native raster format. It's usually referred to as PEG files because the tool names for this are rpeg and runpeg. And here in these examples, I'm using grass_raster as an extension. You could use PEG or rpeg as an extension as well. And now what the API allows is to create a project based on this file. And then when you pass it, when you pass a path to this file, in this case, it's only the file names in the current directory. When you pass it to the tool instead of the name, the API will automatically import it into Grass and do the processing on the file. The imported files are cached as well as the created files are cached. So when you use it together with the context manager in with statement, you will not be importing or importing twice. So it will be fairly efficient. And then one other aspect what we struggled with in the workflows is managing different computational regions. Where for parallelization, for example, we want at the same time change the computational region many times, or sub-processes have different computational region than the main process. And there is an API for that, but it requires a lot of manual work, and the syntax for that is not great. So this region manager allows us to create context where the region is changed to something specific. So in this case, the computation region is changed to an elevation raster, and then whatever tools are called inside that context, they respect that computational region. And we also introduced a mask manager, which works in the same way. That was much more work because for that we actually had to improve how 2D raster mask is handled in Grass C library. So now we can have multiple different masks at the same time. Before it was always only one mask. And the usage in Python is now completely the same. You have mask manager and you specify the name of the mask, and that's what the tools will respect. Before this was almost impossible to do, while now it's actually exactly the same as the computation region. And all of these combine nicely, and they combine with the fact that there is the tools object, So if you are using it in some concurrency case, when you are parallelizing your workflow, you can uh, pass the specific environments from one manager to another and to the tools. And this way you will get an isolated environment for the tools. And what the tools object now is doing is that all this special environment handling is actually done when establishing the context or when creating the tools object. Then the tool calls are the same as before. It's just plain nice tools.runivar, and there is no env passed there, no special treatment for mask or anything. And couple more features uh, in the API. One is how to handle inputs, or specifically the standard text input when it is piped into a tool, like uh, a, a text input in for v in ASCII, where we can pass string, which is then creating a vector map. So for that, the tools API is using a string IO object where we set the input to the in ASCII tool as this string IO object, and then the value of that object is whatever the text we want to pass to the tool is. So in this case, it's a point with specific value. And the API takes care of the rest. This looks very straightforward, and it should. So maybe to appreciate it, let's look at how this would look with the write command function. So first thing, we need to use the write command function instead of the run command function, because we want to pass the output to the tool. So we sort of write to the command. That's the idea there. The tool itself, for standard output, to tell it that we will be sending in standard output, we have to say input equals dash. And then we have a separate parameter stdin, which will be the text input for the tool. So in the new API, it's just one thing. The tool name or the function name is still the same, v in ASCII. And the API in the background translates this to input equals dash, and then passing the standard input to the tool. And then finally, when the tool fails, because it's a Python function, it creates an exception. And the exception contains whatever the tool produced for the error output. This can be customized or disabled with capture output, capture stdr, or errors. You can ignore it, ignore the errors. You can not capture the standard output, so you don't get anything in the traceback, depending on what you need. If you are scripting it and then maybe investigating the result yourself, that would be appropriate. So these are the advanced cases where you can customize. By the basic default cases, it behaves like a Python function. And all this is actually reflected in the documentation of the individual tools. So for example, for rgrow, you see that it has an example with the tools. It provides the general syntax. The individual parameters are described also in the way which is appropriate for Graphs tools, including the NumPy arrays. And as part of a different project, NSF Pose, we improved all of the documentation, even for the command line API and the Graphs script API. So all of this is much better, but the Graphs tools interface just benefits from this the most, because it is most rich in terms of what the data types you can pass to the different parameters. And because Grass itself has some so good description of what the individual tools can do and accept, the Python documentation then benefits in the way that we can actually describe it in the documentation. And the difference between GraphScript and GraphTools, in terms of like how rich it is, you can see it here. This would be the R-slope aspect tool for elevation in the GraphScript run command. It's just string, and that's the name of the input elevation map. But for in the GraphTools API, that can be also ND array. And for outputs, the syntax is a little more complicated, but that's the formal way how to actually specify it. It's the type of ND array or type of NP array is what will cause the tool to return us the raster slope by, or the slope raster by value. And there is even more. There was a lot of work done as part of this project on the create project function, which now works outside of a Grass session, which was unfortunately not the case before. So now you don't have the chicken and egg problem that you need an existing Grass project to create the Grass project with the create project function. You can now do it without it, completely in Python. There is also experimental classes, mapset session and temporary mapset session, which work within an existing session, but will create specific environment just for a given mapset. There are tutorials, specific tutorial for parallelization of overland flow and sediment transport. That was partially funded from a USDA project, but it uses the new API as well as the context managers. And there is a completely new documentation thanks to the NSF post project of the Grass project of the Grass projects and handling of data in Grass in general. So what you should do, I can recommend you to migrate to the new API, but it's not required in any way. It's great for new code and will give you really a lot, although you don't have to use all the functions. You don't have to use the NumPy or the PEG interface. And the cost for not using it or not taking advantage of it is not high. Everything is written in a way that you pay minimal cost for these extra features. It is not considered stable for the 8.5 version. It will be included in 8.5, but we don't expect any major changes to the API itself. There might be some major changes to the implementation, how the things are organized in the source code. There might be some additions, but the API should stay fairly same. But if you require complete stability, then run command family of functions is probably your best friend there. And there are no specific plans to deprecate either run command family of functions or the Grass by Grass modules. So you can keep using them as of now without being too worried. But again, the recommendation is to use the new API, at least recommendation from me. And there is even more. There is a experimental set, although not a complete set of subcommands. So with 8.5, if you do grass create or grass run, you can do things with subcommands in the command line. There is also a prototype not included on the main branch, which creates a command line interface which doesn't need any project setup at all and would only use the standalone rasters or the native standalone rasters. And there is an equivalent Python API for that no project command line interface. However, there is funding needed for doing any further steps in any of this. Finishing the standalone tools or the subcommand interface, there would be a way how to make the raster pack IO faster so that the native rasters don't have to be imported. There is, of course, the clear next step of adding other formats, whether it's packed vectors, like native grass vectors, or things like GDL rasters, which would work in the same way in the API. And parallel to NumPy arrays, we could include GeoPandas for vectors. And also this whole API allows to create alternative implementation. So alternative implementation of tools, one which kind of would be a clear next step again would be a tiled interface where these tools would by default run in a tiled workflow and parallelized rather than what it is there now. But none of this has funding currently, so you can think about what would you like and what you can do for that. If you have questions or suggestions for contracts, you can email me at my university email. If you want to become a Grass contributor in terms of code, there is the Grass GitHub page. And if you want to become a financial supporter of the Grass project itself, you can go to NumFocus.